Now I showed you how to add 1 point to the vehicle's path, but what about many points? It's very easy. Let's go back to our mobile robot script, and let's rename our point variable to be point1, and create a second point. Point2, it has to be a vector. Let's use 2000 for the x and y axis, and a value of 0 for the z. And when you want to add more than 1 point to the vehicle's path, you have to add them immediately after one another. So an easy way to do that is to use a for loop. For p in, I'll create a list real quick, point1 comma point2 colon vehicle dot add control point p. So what we're doing, we're telling the vehicle to go to point1 first, and then go to point2 and stop there. Compile the code, and now let's run our simulation. And yep, there the vehicle goes. It goes to P1, it turns, it goes to P2, and it stops there. You can also tell the vehicle to go to other components, for example the robot. Let's reset. I'll now go back to my Home tab, and with the robot selected, I will move it somewhere over here. And now we want our vehicle to go where the robot is. So let's go back to our script and just comment out this for loop here and your 2 points. And now we need to get the application object. I'll write app equals get application. And we want to find the robot component. Robot equals app dot find component. This allows you to find a component by name. The name of the robot you can see here in the component properties panel is generic robot. So let's use that name. For the robot, we can get its world position matrix in the 3D world. So write WPM equals robot dot world position matrix. This is a VC matrix object, so it does have a position vector, which you can access using its P attribute. So I'll create a new variable called robot point and set it to equal the P attribute of the robot's world position matrix. Let's now tell our vehicle to go to that point. All right, vehicle.add control point, and we're going to the robot point. Let's now compile our code and see what happens. We don't need to see the eCatalog panel, so I will minimize that for now. We just want to see our vehicle go from here all the way over here. Run the simulation, and yeah, buddy, that's what happens. You can also do this a different way. Instead of getting the world position matrix of the robot, what we can do is comment out these lines of code. Let's now get 1 point, which is the vehicle's current location. So in this case, I'll use the component object of our vehicle, comp.position matrix. And remember, we need to work with vectors, so I'll get the P attribute for its position vector. We'll then create P2 equals robot dot position matrix and get its position vector. And now for our robot point, we want to assign a vector to the vehicle that goes from P1 to P2. So I'll write P2 minus P1. This will give us the vector to the robot. Compile the code, run the simulation, and yep, that's what happens. But don't be fooled here. We're working with vectors, so the reference of your vector's point does matter. And I'll give you an example to illustrate this. So let's reset and create a frame feature in our robot where we want the vehicle to go. Because right now we're just using the component's origins, which is a very easy thing to do. But let's get more difficult and use frame features. With the robot selected, I'll go to the Modeling tab. And in the Component Graph panel, I have the root node selected. I'll now add a frame feature. And let's move the frame feature away from the robot along the x-axis to, say, 1000 along the x-axis. And this is 1000 away from the robot. I'll now rename my frame feature to be pick up location. And there we are. So here's the frame feature. And now we want our vehicle to go to where our frame is. So how do you do that? Go back to your script, and instead of using these vectors from the vehicle and the robot, we're going to use our robot object to get that frame feature. So frame equals robot.getFeature. Because the robot component is also a node, and our frame feature is in that node, so we'll use the robot's root node with the getFeature method to find the feature by name, and it's called pickupLocation. Since this is a frame feature, it does give you a node position matrix. So npm equals frame.node position matrix. This is the location of our frame relative to its node. So the frame here, its position relative to the root node here. And we can also get the position vector of that matrix. So we'll say frame point equals npm.p. Let's now tell our vehicle to go there. And let's delete these lines of code here. We don't need them. If you compile the code, oops, sorry, we have to change this. We don't want it to go to the robot. We want it to go to the frame. And now compile your code. But what do you think will happen if you run this simulation? Will the vehicle go here, or will it go somewhere over here? Because remember, we're dealing with vectors. Run your simulation, and the vehicle did not go over here, it went here, because it was assuming when you assign that vector that it was referencing a location relative to where the vehicle currently is, not where the robot is. So to work around that, what you can do, and there are a couple of different ways you can solve this. Let's use the position matrix, or the world position matrix of the robot, and get the world position matrix of our frame feature. So with our robot, we have the frame and the robot component. Let's now get the world position matrix of our robot. So wpm equals robot.world position matrix. And here's the node position matrix of the frame. For our frame point, let's make that equal to the world position matrix of the robot times the node position matrix of our frame feature. And from there, we need to get its position vector. So we're getting the world position matrix of our frame feature by timesing it by the world position matrix of our robot. Compile the code, and now if we run the simulation, show me that magic. Yeah! So now the vehicle goes to our pickup location instead of going over here.